Tonight's video lesson is on ionic compounds. This is video lesson 2.5 for our forensic science unit. You are to watch this for class on Tuesday, 10/23. My objectives for you tonight is that you'll be able to write a Lewis dot structure from an electron configuration. You'll be able to show the movement of valence electrons in the formation of compounds, and that you'll be able to write a compound formula for an ionic compound. Before we get into formation of ionic compounds tonight, let's quickly review Lewis dot structures. And so Lewis dot structures are drawn by taking the electron configuration to determine the number of valence electrons. From that, then, you're going to write the symbol of the element and place as many valence electrons around that symbol as necessary. Electrons are going to be added, though, one to each side until all four sides of the element have an electron dot. Then you're going to add a second electron dot to each side as necessary. So for example here, if I take oxygen, which oxygen's electron configuration is 1s2, 2s2, 2p4. And so we will see that based on our valence electrons here, in energy level 2, we get 2 electrons from our s sublevel, and then we get 4 electrons from our p sublevel. So we have a total of 6 valence electrons. I'm going to then write the symbol for oxygen. And starting, and it doesn't matter what side you start on, I'm going to place one dot on each side if I have enough to do so. In this case for oxygen we do. Then I'm going to go back and I'm going to add a second electron dot as necessary. It does not matter what side you start on or where you end. In the future, it's going to depend on what all you need to draw with it. So I want to highlight with this here that we have these 2 pairs of electrons. And so these are referred to as lone pairs. Lone pairs are going to be important in the drawing of ionic compounds because they don't form ions. These electrons are electrons that are going to stay with the element or the atom. So let's take a look real quick at the formation of ions here. If I, for example, take sodium, and sodium's electron configuration is 1s2, 2s2, 2p6, 3s1. There's 1 valence electron. So if I come down here and I draw sodium with its 1 valence electron, like before, we know that to fulfill the octet rule, sodium's going to want to give up that electron. But where does that electron go? It doesn't just go off into space. And so in order for that to happen, what's going to be necessary is sodium's going to need a place to give its electron. And it's going to need another atom that's going to be receptive to receiving that electron. So if I have chlorine over here, with chlorine being 1s2, 2s2, 2p6, 3s2, 3p5, I have 7 valence electrons. And then chlorine, when we draw its electron dot structure, has 7 valence electrons. And like before, when we drew wrote out the electron configuration for the new ion, chlorine's going to gain an electron from somewhere. But again, where does that electron come from? It doesn't just come from space. In order for an electron to be gained or lost, what needs to happen is there needs to be a chemical reaction that takes place. And during this chemical reaction, what's going to happen is the atoms or the elements that are being mixed together, if they react, they're either going to gain or give up electrons to get to fulfill that octet rule. So sodium here has its 1 electron that it wants to give up. Chlorine has its 7 valence electrons and it wants to gain 1 more electron. If you were to heat up sodium and put it into a jar with chlorine gas, this would react and it would form table salt, or sodium chloride. In doing so, what would happen is sodium would send its 1 valence electron to go and join chlorine. Now, sodium no longer has a valence electron. What's sodium's charge? Sodium's charge is going to be +1. It gave up its 1 valence electron. Chlorine, on the other hand, is now going to have a total of 8 valence electrons. With chlorine having 8 valence electrons, it now has more electrons than it does protons. And so it's going to have a -1 charge. When you draw Lewis dot structures for ions, it's important that you represent on there that if it's gaining to get to 8, that there should be 8 valence electrons now drawn around it along with the charge. Whereas if it's giving up electrons to get to 0, then you're just going to write the symbol with the charge. Now, it is the gaining or giving of electrons that is going to form ionic compounds. And before we said that ionic compounds were formed between a metal and a nonmetal. What's going to happen is the metal gives up electrons because it has a low electronegativity, whereas the nonmetal is going to gain electrons because it has a high electronegativity. And electronegativity, like I said before, has to do with how badly that atom or that element wants the electrons. And they're going to do this to fulfill the octet rule. Once they fulfill the octet rule, both atoms then are going to be pretty stable. And outside of another chemical reaction taking place, which could occur, these elements and these atoms are going to form an ionic compound together. So let's do another example here. If, for example, I take magnesium, which is 1s2, 2s2, 2p6, 3s2, and I take fluorine, which is just 1s2, 2s2, 2p5. Magnesium is going to have 2 valence electrons. Fluorine is going to have 7 valence electrons. So if I draw the Lewis dot structure for this, magnesium is going to be Mg with 2 dots, and fluorine is going to have a total of 7 dots. Okay. So like I was saying before, magnesium is going to want to give up an electron, and fluorine is willing to accept that electron. Now in this drawing, once magnesium gives up 1 electron, does fluorine not have 8? And the answer is yes. So is fluorine going to take on any more valence electrons? No. Once it reaches 8, it's stable. That fluorine atom's not going to take any more on. But if you are doing a chemical reaction, generally you're not going to have just 1 atom of each, and so you're going to have a whole collection of atoms. So another fluorine atom is capable of coming along then and that fluorine atom is going to take the other valence electron that magnesium has to give up. So if we look at our ions now, we've got a magnesium ion with +2 charge. And then we've got fluorine, 2 of them, with a -1 charge. In forming ionic compounds, you can add as many metals or nonmetals, sometimes you may need to add both, until you get all of the atoms involved with it to have either 0 or 8 valence electrons. Once you have them all to 8 or 0 valence electrons, then you can stop. If we were to rewrite this now, we've got 1 magnesium atom, and we've got 2 fluorine atoms. And so I've put next to the fluorine symbol, I put a subscript of a 2 to indicate that there are 2 atoms involved in that ionic compound. Let's go ahead and do one more. A couple rules for writing our ionic compound formulas here. As you start with drawing Lewis dot structures, and get valence electrons to 8 or 0. And I'm going to shorthand valence electron. In doing so, you may need to add more than 1 atom of each. The second part of this is you rewrite with the ions formed. From this step then, you count up all the atoms that are involved in the ionic compound. So you're going to add up metals, so metal ions, and write symbol with subscript. And then you're going to do the same thing for nonmetals. Just remember, write metals first, then nonmetals.